Bismillah ar-Rahman ar-Rahim. So let's talk about the mechanical equivalent of heat energy in the theoretical part. When we measure the specific heat capacity of a solid, we use this equation. Q is equal mass multiplied by specific heat capacity multiplied by temperature. And this is basically we are dealing with heat energy. We are dealing with heat energy. And at that time, we gave it the unit calorie. The unit calorie. When they develop this theory to deal with heat energy, another group of scientists were developing another measure or another unit, not to measure the heat energy only, but to measure all kind of energy: electrical energy, potential energy, kinetic energy, heat energy, magnetic energy, anything, source of energy, we can measure it, and they gave it the unit joule. The unit joule. Now, when the two different groups met, they have no idea what is the relation between joule and calorie, and how much calorie in terms of joules and how much joules in terms of calorie, until Joule himself suggested this experiment. So in this experiment, he put water in an thermally isolated container, and he said, well, if we stir the water or we shake the water, that means we are putting some energy, outside energy, and that energy must raise the temperature of water. So here there is a thermometer. So he suggested this setup. We have two masses. They are attached to this pulley, and when the two masses go down with gravity, because of gravity, they will make this pulley move, and then they will make the water, they will stir the water, and basically the temperature of the water will raise up. So when you use a Q with calorie, we know that mCt. So if we put delta Q, that means delta T, T2 minus T1. So temperature at the beginning and temperature after those two masses goes down, then basically we know how much energy we pumped inside the water. So here we know as a fact that if this is H, then what's the potential energy that mass has? Well, potential energy is equal M multiplied by G multiplied by H. And what's the units here? It's joule. The unit is joule. And how about here? Well, when this energy is transferred inside the water by stirring the water or shaking the water or making water move, well, we can get our Q in calorie. So right away we can know how much or what is the relation between calorie and joule. The best number Joule got for the relation is like 1 calorie is equal 4.15 joule. The best number we know right now for the chemical calorie, it's 4.184 joules. That's the chemical calorie. And of course, there is a reason for this limitation because we are losing a lot of energy in friction. Here there is friction, and also here there is friction. So we are losing significant amount of energy for friction. So we can't estimate, we can't find the exact or the accurate relation between joule and calorie. So instead of mechanical equivalent, we will do electrical equivalent because there is no moving parts, so we don't lose energy to friction. Well, we know that suppose that we have a volt potential and we have current, then the power, electrical power, is simply voltage multiplied by the current. And also we know from previous lectures that power is also work divided by time. This is time. We have two T's. The capital T is temperature, the small t is time. So if we want to know the work, must multiply power with time. So that means the work done using our electrical circuit is voltage multiplied by current multiplied by time. In this, the units is joule. And also we have our container, thermometer, and we have some resistance connected. So we know that Q is equal MC delta MCT. So we start our experiment when the time is equal 5 minutes, which is 600 seconds. We take a measurement. So we measure the water. The first time we measure the water, it's about 200 gram. C for the water is 1, and we just measure the temperature. So at 5 minutes, we look at the thermometer and we take the temperature. Then at time is equal 10 minutes, also we take a measurement for the temperature. So we have T1 and T1, T2 and T2, etc., until we reach 25 minutes. So we just do a graph, Q versus joule, or Q versus E, sorry. The unit here is joule and the unit here is calorie. We have our data points and then we find the slope, and the slope will give us the relation between calorie and joule. It is important here to mention, for simplicity and for simplicity only, we neglect the calometer. Why? Because as the water is heating, the calometer also is heating. So part of the energy will go to the calometer. So for the sake of simplicity, we ignored the calometer. However, if we want more accurate results, we need to consider the calometer in the equation. So part of the heat will just be absorbed by the calometer. Now in this experiment, it is important to know that V has an error, I has an error, T, the time, has an error, capital T, the temperature, has an error. Mass has an error. So all of those things have error. Also, when you calculate E, you need to find the error of E. And when you calculate Q, you need to find the error of Q. All of that in the table. And if you don't put the error, the table, you will just lose the whole mark of the table. The table has to be filled with all error, with all error. And of course, the error is very easy. I mean, E is equal VIT. Error of E over E is equal error of V over V plus error of I over I plus error of T over T, and etc. for Q. That's it. Thank you for listening.